Now, one type of substitution called a rationalizing substitution many times will result in partial fractions. So we also want to consider these substitutions in this section. So here we want to integrate square root x minus 1 over 3x dx. Well, notice that this is not a trig substitution because there's no square. If it was an x squared minus 1, then we'd be thinking about a trig substitution. However, here, the problem in evaluating this integral is that square root. So we're going to use a rationalizing u substitution, let u equal the square root of x minus 1. So then if you, before you find du here, let's square both sides. So u squared will be square root x minus 1 squared, which will just be x minus 1. And now take the differential of both sides. So on the left, 2u du will equal, on the right, derivative with respect to x is 1 dx. So let's go ahead and change this over. So integral square root u minus 1, that's our, square root x minus 1, that's our u on top. The 3, let's go ahead and pull that out in the front. So 3 in the denominator will be a 1/3. And then we've got that x. Well, let's see, u squared is x minus 1. So if we bring this x over on the left as a positive, we get u squared plus 1 is equal to x. So that's in the denominator. U squared plus 1. And then our dx, right here. dx is 2u du. So times 2u du. So the 2, we'll factor that out in front with the 1/3. So we got a 2/3 integral. U times u squared in the numerator. And in the denominator, u squared plus 1. And du. So this is a rational function. It's going to be partial fractions, could be the easiest way to do that. Notice the powers are the same, so we need to long divide. U squared plus 1. We're going to divide into u squared. We could write plus 0u plus 0 if we want. So remember, you divide the leading coefficients. U squared divided by u squared is equal to 1. So you get a 1 here, times u squared plus 1. So u squared plus 1, and we subtract. So change our signs and add. Minus, minus, plus. These guys cancel. 0 and -1, -1. So this will be minus remainder 1 over divisor, u squared plus 1. So this is going to equal 2/3 integral 1 minus 1 over u squared plus 1. So this du. So 2/3 out in front. Antiderivative of 1 is just u. Antiderivative of 1 over u squared plus 1, that is inverse tangent. So inverse tangent of u, and plus constant. And now we just have to plug back in, u is root x minus 1. So 2/3, got root x minus 1, minus inverse tan, root x minus 1, and plus a constant. And we got it. So there we actually only had to do the long division. We didn't have to do an actual undetermined coefficients. So that worked out nicely.